8.6, DeMoivre's theorem, powers and roots of complex numbers. We start with DeMoivre's theorem, and it's going to allow us to take a polar vector, r cis theta, to a power. So we want to take a polar vector and raise it to a power. Here's what happens. You're going to take that r number to the nth power, and then you're going to multiply n times theta. Pretty simple. So example 1, we've got a polar vector, 3 cis 50, raised to the 4th power. We're going to say 3 to the 4th power and 4 times 50. 3 to the 4th power, 3 caret 4, is 81. 4 times 50 is 200. That's all there is to it. We just took a polar vector to the 4th power. Now let's do 2 cis 60. DeMoivre says 2 to the 8th, cis 8 times 60. 2 to the 8th power is 256. 8 times 60 is 480. There we go. All right, I'll do those all day. Number 2 is a little bit harder, okay? We're still taking a complex number to the 4th power, but this time you might notice we are in rectangular form, whereas above we were in polar form. So DeMoivre's doesn't really apply here because we don't have an r and a theta. But it's not like we don't know how to do this. We may not want to, but we know how to do this. 1 plus 2i to the 4th power. We could always expand it and multiply it out. Okay, 1 plus 2i times 1 plus 2i times 1 plus 2i times 1 plus 2i. Not very fun, but we can do this. Let's look at 2 of them at a time. So if we look at these 2 and distribute, FOIL, whatever you want to call it, 1 times 1, 1 times 2i, 2i times 1, 2i times 2i. We get that. 4i squared. Remember, I squared is negative 1, so 4i squared is negative 4. And we can clean that thing up. 1 minus 4 is negative 3. 2i plus 2i is plus 4i. Now, think about it. We'd have to do that again because we've also got these 2 over here. So we're going to do the exact same thing. And if you're smart, you're going to skip all the work because you're going to recognize that it's going to be the exact same result. You know, if you don't realize that, you can still FOIL. But at some point, you need to realize that that's just going to be the same thing, and you're going to get another negative 3 plus 4i. So guess what? We've gone from 2 binomials down, or from 4 binomials down to 2, and we're going to have to FOIL again. We're going to have to multiply this out. So we just do the same kind of deal. Distribute, and you get 9 minus 12i. Distribute, you get minus 12i plus 16i squared. I squared is negative 1, so we know 16i squared would be minus 16. Combine the like terms. 9 minus 16 is negative 7, and negative 12i minus 12i is minus 24i. There we go. I'd probably rather do DeMoivre's. It's because polar form is usually going to be easier than rectangular form. But again, it's not like we can't do it. We know how to do it. We're going to expand it out and multiply it out. Okay, fine. What are your thoughts when you look at part B? You're like, oh my gosh, I don't want to do this. 6, 7, 8. we're going to have to do the same thing out, like FOIL it out like a whole bunch of times, okay? No way. I don't want to do that, okay? I don't want to do that. I wouldn't think you'd want to do that either. I'm not going to FOIL this out like a million times, and we don't have to do that because we can do kind of what we did before. We can change this thing from rectangular to polar. Let's convert. We did it in the last lesson. Let's convert it to polar. Let's use DeMoivre's. Let's do that. That's going to be a lot easier. Okay? So remember how we changed to polar. We've got those formulas. We can say r equals square root of x squared plus y squared. Write small. You don't have a whole lot of room. So in this problem, x is 1 and y is square root of 3. So we have 1 plus, remember, square root squared cancels out. So that's going to be 1 plus 3 is 4. Square root of 4, r is 2. R is 2. We also need theta. And we have this formula, tangent theta equals y over x. And so in this specific problem, remember, y was square root of 3 and x is 1. Now you can reduce that if you want to. It's just going to be square root of 3. But this is where the calculator comes in. You're going to do an inverse tangent. So we're going to do an inverse tangent of square root 3. And there's not really any need to do over 1. That doesn't do anything. You can type it in if you want to. Make sure you're in degrees. And we get 60. Now remember, that may or may not be the answer. That's the reference angle. You have to think about what quadrant we're in. If we're in a certain quadrant, it's going to change the answer. But notice this complex number, 1 plus I squared of 3, is in quadrant 1. And so if we're in quadrant 1, 60 is just 60. And so it turns out that theta is 60 in this case. If we were in quadrant 2, 3, or 4, it would be something else. But for right now, we've got theta equals 60. And so we haven't taken it to the 8th power yet. All we've done so far, what we've done is we've changed the problem to 2 cis 60. Okay, now keep in mind, we still have to take it to the 8th power. But that's the easy part. That's DeMoivre's. And honestly, we just did that up here too, right? 2 cis 60 to the 8th power. We did that right here. Okay. That's pretty quick. We know DeMoivre's is going to say 2 to the 8th cis 8 times 60, or 2 to the 8th is 256 cis 480. Okay. So that blue right there, that's DeMoivre's, and that's the answer, sort of. Here's the problem. Only problem is this. If the problem starts in rectangular form, you're probably going to want your answer to be in rectangular form. Okay? So we're going to go one more step, and we're going to convert. But that's fine. All we do is 256 cosine 480 and 256 sine 480 with an I on it. So what I like to do is just type it in, 256 cosine 480. Sometimes it's just a nice number. Sure enough, 256 cosine 480 is negative 128. So great. Let's try 256 sine 480. Okay. Weird number. Remember what I told you to do on a weird number like that. Split it up. You've got 256 and then whatever this is. Let's just look at sine 480. Sine 480 is 0.866. That's one of those numbers, right? I told you to remember. There's some certain decimals pop up all the time. And 0.866, very good. Square root of 3 over 2. If you can make that adjustment, then we can cancel, and that's 128. And our answer looks like negative 128 plus 128 square root of 3 with an I on it.
So the I can go after the The square root of 3.
The I, as long as the I is on your second piece, I don't really care where it goes. Sometimes people will put it in front of the 128, and sometimes people will put it in front of the square root of 3. Somebody told me that Math Excel just makes you put it at the end. So, just as long as it goes on that second component, you'll be fine. All right. Now, remember, this was also the answer, right? It was just in a different form. This was in polar form. This is in rectangular form.